Okay, there will be a quiz tomorrow, and it's going to be on a standard form of the parabola, and I'm going to ask you all the information that I requested on the homework. All right, so we're going to understand polynomial vocabulary today. We are going to use the leading coefficient test to determine end behavior of a polynomial. Finding zeros of a polynomial, I think maybe. Definitely have to determine multiplicity. We're going to investigate that tomorrow. You'll have notes on that Wednesday. Determine the maximum number of turning points of a polynomial, and then we're going to graph them. All right. And actually, it's going to be a relatively loosey-goosey sketch. All right. So a polynomial function is a function whose exponents are whole numbers and whose coefficients are real. So to be a whole number, oh, there we go. I have it. Whole numbers are numbers 0, 1, 2, 3, no fractions, no decimals, no negatives. However, coefficients can be real numbers. So I think my question here, is that a polynomial, yes or no? The exponents are 5, 1, and the coefficients are real numbers. This is a polynomial. Is this a polynomial? That 3 is supposed to be under the 2. The exponents are whole numbers, and 2/3 is a real number, so this also is yes. Is this a polynomial? Pardon? No, this is not a polynomial. Why? What is that? X to what power? Right, that's a fractional exponent. That is not a polynomial. What about this one? Why? Right, so now that's real obvious, isn't it? Do I have any more? Oh. Now, what about this one? Okay, but there's a square root. Why is that square root okay? Right, see how it stops short of x? And so that's x to the first, that's x to the 7th. What about this one? Why not? Because that's an exponent of -3, which ultimately puts it in the denominator of a fraction. I do believe this is part of your homework tonight. Is this the fast part? Mm-hmm. All right. So that's our beginning vocabulary. Oh, okay. Degree. Degree of a polynomial is the exponent that is the largest exponent. So what is the degree of f? 7. Okay, the degree is the exponent, not the coefficient. What is the degree here? Okay, what is this degree? Notice these are not in standard form, are they? Make you look for it. What is this degree? Ooh. How do you know? Okay, to get the biggest degree, you're going to be multiplying x times 2x, and that's going to be 2x squared. Everything else is going to be just x to the first, so your degree is 2. What do you think your degree is going to be now? 3. What about now? Why isn't it 2? What does that say? That's going to be a squared x times that x is going to give you x to the. So now what is this degree? Because that's going to give you an x cubed. This is going to give you an x squared, which gives you what? X to the 5th, and when you multiply it by this, it'll be x to the 6th. Okay, suppose, let's pretend that had been a squared, and that, yeah, now what would that degree have been? X squared times x times x. Any questions? being able to pick out the degree is really important for our end behavior that we're going to do today. Now, leading coefficient of a polynomial, and this is another key piece. There's two key pieces for end behavior, Madison. There's the degree of the polynomial, and there's the leading coefficient. So who can tell me the leading coefficient for the first one? So I'll call it LC, 5, because the highest degree is 7 and its coefficient is 5. What's the leading coefficient on this one? 2. What is the leading coefficient on this one? Uh-oh. Because that's going to be 2x squared, so the leading coefficient is 2. What is this one going to be? It's going to be 2x times x, which is 2x squared times x, which is 2x cubed, so we got 2. What about this one? Oh, what's happening to 4? It's going to be 4x plus 1 times 4x plus 1 times x plus 3. So multiply all your x's, you're going to have 4x times 4x is x squared times x, x cubed, so 16. All right. Yes. Okay. So this is being squared. So I wrote it out. So to get your degree and your leading coefficient, you're going to multiply all your x's. So you get 16x squared times x is 16x cubed. So the leading, or the degree is 3, the leading coefficient is 16. All right, what about this one? That's going to be 1 cubed. What is this one going to be? 1 squared times what? So what is that going to be? 3 for your leading coefficient. Any questions there? Okay, a function said to be continuous if there are no holes, no breaks, or vertical asymptotes. In other words, you can trace a function without lifting your pencil. A function is said to be discontinuous if it's not continuous. Is this continuous? Why not? There's a hole. Is this continuous? Why? Vertical. Is this a continuous? Is this continuous? Is this continuous? That was an easy concept. All right, so here's our end behavior. End behavior describes what the function is doing as the x values go to positive and negative infinity. Maybe I want to go a little bit further and say, when I say what the function, we want to qualify that to be what the y values are doing as the x values go positive and negative infinity. So this is read as x approaches positive infinity, f of x, another name for y, that arrow means approaches, and then what? How many people have done in behavior? Pre-calc, maybe? Calculus? Pre-calc, anybody? Somehow, it used to be in pre-calc. It's been a while since I taught it. So if I want to do in behavior, I would say as x approaches positive infinity, comma, f of x. Okay, approaches. As x approaches negative infinity, f of x approaches. So, as we go to the right forever, what are the y values doing? Going up forever. As x's go left forever, what are the y values doing? Going up forever. What's this degree? 2. All right, so now we're going to come over here. Notice as x approaches positive infinity, f of x approaches. As x approaches negative infinity, f of x approaches. The book writes it weird. This is how I want it written. If you write it the book way, then I know you looked at the answers in the back of the book and copied. And you didn't pay attention to my notes. All right. So, as we go to the right forever, what are the y values doing? Up forever. As we go to the left forever, what are the y values doing? Up forever. All right. What degree was this? 4. Oh, wow. It was already written. Okay. Try another one. All right. So now what degree is this? What degree is this? What's the common? Yes. So now as x goes to the right forever, positive infinity, what are the y's values doing? Going down forever. So in behavior, do you see how this is always the same? It's just filling in the blank there. As x goes left forever, what are the y values doing? Going down. As x goes to right forever, what are the y values doing? Going down. That's how we say down, negative infinity. As x goes left forever, what are the y values doing? Down, negative infinity. So, no matter which direction x went, what can you tell me about the direction of the y's? Or, in other words, they were and what was the degree? Even. Okay, so now, what is the degree? Odd. What is the degree? Odd. Now, as x goes to the right forever, what are the y values doing? Going down. As x goes to the left forever, what are the y values doing? Going down, down. Nobody called me on that. As x goes to the right forever, what are the y's doing? As x goes to the left forever, what are the y's doing? Now what's happening? They're different. What's the degree? Odd. Okay, so let's look at the next one. Okay, what's the degree? 7? 9? It's still what? Odd. Okay, so as x goes to the right forever, what are the y values doing? Going up. As we go to the left forever, what are the y values doing? As x goes to the right forever, going down, left forever. Isn't that interesting, little bumpies? Okay. In behavior, if the degree of the polynomial is even, let's go back and look at the evens again. All right, what was the sign of the leading coefficient? Positive or negative? Positive or negative? What was this? Positive. And what did the y values do? Go up. When the leading coefficient was negative, what did it do? And does it make sense? Because in a parabola, when you're negative, a is negative, it opens down versus opens up. Let's look at the odd ones. When the leading coefficient was negative, all right, what happened? Basically, it fell, correct? It went in this direction. When the leading coefficient was positive, what did it basically do? Rose. And that's how you're going to do those. All right, so let's go back to our notes. When the polynomial is even and the leading coefficient is positive, then the shape of the graph is like this. And the end behavior is, as x approaches positive infinity, f of x approaches positive infinity. As x approaches negative infinity, f of x approaches still positive infinity. But when the leading coefficient is negative, then your graph's going to look like this. So in order to describe the end behavior, and I tend to draw these so I do my end behavior well, there would be as x approaches positive infinity, f of x is approaching negative infinity. As x approaches negative infinity, f of x is approaching negative infinity. So I want you to be able to look at an equation without its graph and tell me the end behavior. Okay? And it's all about the leading coefficient. So now let's summarize the odds. When the degree of the polynomial is odd and the leading polynomial or the leading coefficient is positive, then the graph looks the graph basically is rising. You with me? It can have multiple little bumps there, but ultimately it is rising. So then this is going to be as x approaches positive infinity, f of x approaches positive infinity. As x approaches negative infinity, f of x approaches negative infinity. But when it's negative, then its basic shape is going to be falling. So the end behavior is going to look different. As x goes to the right forever, the y values now are going down forever. As x goes to the left forever, the y values are rising. So everybody understand how I want the end behavior written. All right, I don't remember what the book does, but it's just really bizarre. All right, so don't pack up yet, I'm not done. So describe the end behavior. The first thing you are going to focus on is not the first term, but the term with the degree. The degree is 4. Degree 4 even. Then you look at its leading coefficient. What do we have? Negative. Then you draw yourself a picture. And then it's a piece of cake. As x goes to the right forever, f of x is doing what? Negative infinity. As x goes to the left forever, f of x, well, goes where? Negative infinity. All right, if we look at this one, what is the degree? The degree is 3. And what is the positive or negative? Positive, which means we should be rising. So that means as x approaches positive infinity, f of x approaches what? As x approaches negative infinity, f of x approaches what? You got it? Okay, so we're good. I hope we don't... I don't know if we have zeros or not. We don't? Okay.